Now that the lamps have been taken care of, the next phase in the refurbishment is the recap process. So as capacitors get old, like me, they fail and they get leaky, they go short circuit, their values usually diminish, and so you get hum in the amp, and if it's in the signal path you get a degradation of the signal path. So after a while they all need changing. Not all of them. The electrolytics in particular are prone to aging, and I think the film capacitors as well. The other types don't. So I bought a kit to do all of this, but this video is just going to cover getting myself set up with the right test gear, because I didn't have the right test gear. You need an oscilloscope, and I subsequently found out that I really need a capacitance meter as well, which I have on order before I get into the real nitty-gritty of it. Anyway, enjoy. Okay, so this is the first in the series of recapping my C28. It's been a long time, but I've got the caps now and I've got the test gear, and the heart of the test gear is an oscilloscope. I need an oscilloscope to see what the hum is, and to also check the signal paths through the preamp. So I bought one. It's after long deliberation, I bought a picoscope, which turns my PC into an oscilloscope, and so far so good. It seems to work. And also I need a tone generator. Well, I'm using my iPhone as a tone generator, so luckily it works as a tone generator and allows me to take videos at the same time. So I've just got channel A working, and I'm putting out 1 kilohertz, and the scope probe here is on the output. These RCAs are actually the output of this iPhone, and it's producing 1 kilohertz on both channels. And we can go to the screen here, and I don't know if it's in focus or not. It should be, but using the frequency measurements here, I can tell that it's 1 kilohertz, and it looks like this this software is going to do an awful lot of stuff, much more than I want it to do, at least now anyway. As long as I can measure frequency and amplitude, I'll be okay. So that's that. I've figured out how to measure frequency. Let's see if I can do amplitude. I got it set up now, so I'm measuring frequency and amplitude. So I've got the cursors working. So I think we're good to go. All we have to do now, next step I suppose, is to get the amp on the table, get the signal generator through it and the scope on the outputs, and measure all of the paths through the amp, just to make, just to make sure that they all exist, and then take a look at what hum is on it at the moment, and then as I replace the capacitors I can check as I go, just in case I make a mistake. So that's for next week. I'll start that tomorrow, probably on Monday, but as it's Sunday here now, not going to do it today. But anyway, the system works, so that's good. Step 1. Bye bye. All right, step 1 is to check the signal paths through the amp. I'm not interested in anything else at the moment, so turn that off. It's all been relamped, so all the lights are on. This phone that I've got is also my tone generator, so I've got that going into the aux input, and I'm looking at the main output, and this is the left channel and that's the right channel, the same within a smidgen. Okay, so I've got both waveforms switched on now. I've got two scope probes going in, one on the left, one on the right, and the traces are overlaid at the moment, but if I tweak the balance, you'll see the differences in levels. So I'm just gonna get that set up there and go through and check all the inputs to the outputs. I'm not interested in hum right now or anything else. I already suspect that the other output, whatever they call it, there's a level imbalance, but I'll have to sort that out later. So anyway, carry on. So I've switched to tuner. Well, I've switched to the tuner input, select tuner, and we have it there. Do we have both channels? Yes, we do. Okay, tuner is okay. So we're going to try one of the low level inputs right now. So this is the tuner, so next comes phono 1. So I'll switch over to phono 1. Switching over to phono 1. And there it is. Both channels are pretty well the same, but you can see there's a volume difference between the two. So it looks as though the phono levels are a bit skew with. They'll probably need to be adjusted once it's been set up, but this is the value of what we're doing now, because when I go through it afterwards I'll see that there's a difference, and I know it was like that before I started, so I won't be tail chasing. Okay, let's see if we can get phono 2. Alright, switch over to phono 2 and about the same. So both the phonos are down, and we've got trimmers here, but they're all flat out. So something is a little bit not very nice about that. That's the mic input, and I've had to reduce obviously the level of the tone because mic is very low, and there's an input there for direct off the tape head. Let's try that. I mean, I'm never going to use these, but let's try that. The other important ones I haven't done yet are the tape inputs, so we've got to try those. And you can see we're now switched to tape head input, and we've got an output. So those outputs are working all right. Next comes the proper tape deck line inputs, most important. We're going to try tape 1. We're going to try tape 1. So it's connected up round the back. Tape 1 is there, and we have it there. It's a bit noisy. It's noisier than the others. It's probably hum. We'll find out in a minute. We'll just finally try tape 2. So I'm connected up round the back, switch tape 1 off, tape 2 on, and we have it there. This one not quite so noisy, maybe? I don't know. I don't know. So that's a terminated input, and it looks like I'm getting about 1.3 millivolts of sort of 60 cycles and about 6 millivolts of noise spikes from somewhere. Excuse my rough and ready diagram, but you can see the bottom arrow pointing to the really spiky bits and pieces. That is high frequency noise, and the top arrow I've just drawn a rough and ready sine wave, which is at 60 Hertz. That's the hum. And so that's a datum. We'll see we'll have to see why that might be. I might try it on something like the aux input as well. See about that. No change. That is the noise that the amp is making. I haven't got anything selected to the input. So okay, I got my datum set. Seems to work through the amp, and I know roughly what noise it's creating and what the hum is, so it's time to get to work. Okay, see you later. The next step is going to be to take the front panel off to avoid damage. Then we've got to open it up, and then today's task, should I choose to accept it, is to identify all of the can capacitors that have got to be replaced, because that's the most difficult part of it. It's not immediately obvious. I've got the circuit diagrams, but it would have helped me a bit if they would have included a component layout, which they didn't, so I've got to identify them, and you can see how I do that as we proceed. The first step is take the top panel off, and that gives us access to the main smoothing can capacitors. And you can already see that someone has been in here, because this fucker shouldn't be there. What that is doing is sitting across one of these capacitors in here that's probably failed, and as long as it's not gone short circuit, it's all right, you know, because capacitors in parallel add up. So if it's just gone low capacitance, then that'll work, but of course if the capacitor in here is shorted, then it wouldn't work. But it seems to be working, so that's what it is. So I have to identify what that is strapped across, because in each one of these cans there's more than one capacitor. It makes it more difficult. So next step is I'm going to take the front panel off next, get that out of the way. It won't be going back on again until all this is finished. Well, actually it won't be going back on again. I'm going to pack it up and put it in my hand luggage to take it back home, because this is very, very similar to an iPhone screen. I've only got to look at it and it'll crack. So no matter how carefully I pack up the amp in an armoured box, chances are it will still break. So let's get that off next. The front panel is off, and the top and bottom panels are off. And once we've opened up the bottom panel, this is the area we're interested in today. So you can see that each one of these big caps here has got quite a lot of connections on it, and they all go to different places, and that identifies it. And this puppy here looks like it's an addition, so that'll have to come out. And also there was another capacitor under here that you may have seen me remove last time, because one of the screws holding the feet on had gone right the way through it, and that was someone else's bodge as well. So now we've got to identify which of these caps is which. So what I'm going to do is take a series of photos, and we can use that to track it all down. So I took loads of photos like this. You can see all the wires coming off the different terminals, and then I work through and compare it to the circuit diagrams and figure out which of these cans have which capacitors in. I'll show you the circuit diagrams and explain. I'm starting off with the two smaller cans because they're easy. Each one has only got one capacitor in, so even I can't really go wrong. And this was the first can, and this one will be the circuit diagram around the second can. So now I've just got to trace these wires and make sure they go to where I think they're going, and then mark them on a sketch. But this is the circuit diagram that concerns the remaining 2 cans, and each one of these has got 3 capacitors in, so what I've got to do is check the circuit diagram against what's reality, what's actually wired up underneath the board, and make notes and make sure I know which terminal is which capacitor, because you'll see when I actually tear these apart and restuff the cans, it's vital that I get the right capacitors on the right terminals. And the outcome of all this labour, and it took me all afternoon, is this masterpiece that Michelangelo would be proud of. And you can see the 2 cans on the left, they're the simple ones, they've only got 1 capacitor in each, and the other 2 on the right, well, they've got 3 in each, and they're flying off to all different sorts of diodes, transistors, and God knows what else. So it's all documented now, and therefore the next job I will be tackling the easy ones. Of course, I'm a bit of a coward, so I'll get back to you when I start that.